Welcome for another lesson. In this lesson, teaching binomial expansions. And I'll be finishing the same topic later, but I'm just going to use it. Binomial expansions is simply an algebraic expression which has two terms. The word bi means two. Therefore, an expression which has algebra, or in other words, an algebraic expression which has two terms is called a binomial expansion. For example, you can have 2a plus b. It has two terms, this term plus another term. It's a binomial expression. A minus c, x plus 3y. Such expressions are called binomial because they got two terms. Now, in this case, let me get the duster. In this case, we'll be looking at how the binomial expressions can be expanded. I remember in book 2 when we were doing quadratic expressions and expansions and equations, we saw how a term like a plus b can be multiplied with another like 3c plus d. We saw how such an expression can be expanded, whereby we take a and we multiply it with 3c plus d plus b multiplied again with everything in that bracket. Then we expand and we group like terms together. In this case, we will be doing the same thing. So we are just building on the concept which we got in book 2 on how we expand expression. So we can consider a binomial expression like a plus b raised to different powers, raised to 0, and we know that any number raised to 0 is 1. A plus b raised to 1, any number raised to 1 remains itself. These are according to the laws of indices. Anything power 0 is just 1. A plus b raised to power 2. According to the identities in quadratic expressions or the quadratic identities, we say that when we have a binomial expression like this squared, we take term squared plus 2 times the terms, then plus the last one squared, b squared, like that. The other term, we can go to the same term, power 3. This one will involve some work now. Power 3 means a plus b times a plus b times a plus b again, like that. So a plus b times a plus b is already a plus b squared. So this one is already multiplied, therefore we are multiplying it again with a plus b. So it's a plus b times squared already is done. So squared plus 2b ab, plus b squared. Therefore, opening the bracket, we will have a times everything, a squared plus 2ab plus squared plus b again with everything. So opening this one, we shall have a power 3 plus 2a squared b plus b squared a plus b a squared plus 2a b squared plus b cubed. Therefore, we shall have now the like terms grouped together. A cubed is only 1. A squared b and another a squared b is here. Therefore, 3a squared b plus b squared a and another b squared a is here. Therefore, b squared a and 2a b squared, they become 3a squared b plus So this and this and this combined remain with b power 3. Therefore, the term we get is this one. The term we get is this one. We can check the same raised to power 3. A plus b, not power 3, now power 4, which will be a plus b multiplied with a plus b power 3. And the power 3 is already gotten. Therefore, we just have a plus b times power 3 is a cubed plus 3a squared b plus 3a squared b plus 3a b squared. It is b which is squared now, plus b power 3 plus b power 3. Therefore, when we multiply, we will have a into everything plus b into everything so we can multiply a becomes plus 3a power 3 b plus 3 squared plus b power 3 a plus power 3b plus 3a squared b squared plus 3a b power 3 plus b power 4. So grouping like terms together, we shall have a power 4 plus a power 3 and b, they become 4. So 4a power 3b, these and these, they are like that. Then a squared b squared, it is 3a squared b squared and 3a squared b squared, they become 6. A squared b squared plus b power 3a, b power 3a, b power 3 times a, b power 3 times a, let me check my work well. These terms are 1, 2, 3, 4. So 1, 2, 3, 4. And here we had 1, 2. This is b power 3a. And this is b power 3a. Therefore, 3 of them and 1 of them, they become 4. They become 4. Therefore, 4 b, or we can start with the a b power 3, then plus b power 4, like that. Therefore, we can now assemble all the expansions now together, so that you may draw a certain conclusion. There is a certain conclusion I am aiming at. A plus b power 0, we say. Therefore, we can be getting the coefficients here. We can be getting the coefficients here. The coefficients. The coefficients can be coming to this side. So we have power 0, we have one term, and the answer is just 1. So a plus b raised to power 1, we said it remains itself. Therefore, it's just a plus b. And the coefficient here is just 1, but the coefficients here for a and b, they are 1, 1. The coefficients just 1, 1. A plus b raised to power 2. A squared plus 2ab plus b squared. So the coefficients are 1, 2, 1. A plus b power 3. We have a power 3 plus a power 3 plus 3a squared b plus 3ab squared plus b power 3. Therefore, the coefficients are 1, 3, 3, 1. A plus b power 4 is just above, where we shall have a power 4 plus 4a cubed b plus 6a squared b squared plus 4ab power 3 plus b power 4. So the coefficients in this case are 1, 4, 6, 1, 4, 6, 4, 1. Therefore, we can draw a few calculations here according to how the expansions are giving us some results. We should note that with a plus b raised to different powers, in each case here, for power 4, we can say in each term the powers are totaling to 4. For 3 to be totaling to 3. Like in this term, we have a power 4, so the power is 4. In this term, we have a power 3 and b power 1, so 1 plus 3, we get 4. A is power 2 and b power 2, so 2, 2, totaling to 4. And b power 3, totaling to power 4, which is 4. Therefore, again, we should know that as the power of a decreases, the power of b increases. The power of b increases. Therefore, you realize we start when 4 is to power 4, a is to power 4, but b here is to power 0 because it's not there. In the second term, a has gone to power 3, but b has raised to power 1. A has gone down again to power 2, b is still increasing. It was 1, now 2. 2 here, it becomes 1, b was 2, it goes to 3. Then lastly, a goes to 0 as b raises to 4. Therefore, as the powers of a descend, then the powers of b are ascending. They are ascending. Therefore, you find now as the powers behave in such manner, they are giving us coefficients which have a certain correlation, and these coefficients are the one which will take us to what we call the Pascal's triangle. The Pascal's triangle. The first term when a binomial is raised to 0 is 1. When raised to 1, the coefficients are 1 and 1. So we just drop the 1 here and 1 there again. When raised to power 2, So this is the power or the index. And these are the coefficients or the constants in the binomial, in the Pascal's triangle. So index 0, we get that. Index 1, we get just 1 and 1. For index 2, we drop this one here. Then 1 plus 1, we get 2. Then we drop 1 there. We drop 1 there. So the circle grows. The circle grows. When the index is to power 3, we drop 1 here. The terms are increasing. Then 1 plus 2, we get 3. 2 plus 1, we get 3. Then 1 alone. We drop 1 there. So you realize those were the coefficients. When it goes to power 4, we drop 1 here. Then 1 plus 3, 4. 3 plus 3, 6. 3 plus 3, 4. Then 1. Therefore, you realize that the coefficients when it was to power 4 are 1, 4, 6, 4, 1. So in case we continue to power 5, you realize that we are landing at 1. Then 1 plus 4, 5. The other coefficient will be 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. Then 1 ends the coefficients. And the triangle goes downwards. You find it's a triangle. The triangle. The terms are increasing as the index increase. For 6, we will have 1, 6, 15, 20, 15, 6, and the 1 ends again. So downwards, they increase like that. Therefore now, without following the long method of multiplication, then we can multiply binomial expressions in this manner using the coefficients. Let me now simplify these things. If you are told expand a plus b power 4, instead of the long method of expansion we've gone through, we have concluded that as the powers of a descend, the powers of b ascend. Therefore, the first term in the expansion will be a power 4, but b is power 0. The next term will be a power 3 and b power 1, because the powers of a have started to descend as the powers of b now increase. Then a descends to 2 and b increases to 2. Then the other one, a descends to 1, but b increases to 3. Then lastly, a descends to power 0, which becomes 1, and b increases to power 4. Therefore, those will be the terms. Now, these are the terms without coefficients. Without coefficients. Now the coefficients for 4. For power 4, because we have known them. For power 4, because we have known them. They are 1, 4, 6, 4, 1. Therefore, we insert the terms now, and we had, therefore, to be a power 4 times 1 is a power 4 plus 4 a power 3b plus 6 a power 2b power 2 plus this one times 1. Therefore, when we insert the coefficients now, the coefficients for power 4, which is this. Therefore, in case it was the same term, a plus b power 5, then we will have powers of a decreasing as the powers of b ascend, and we insert the coefficients for 5. The coefficients for power 5, which are these ones. Therefore, we will have a power 5. The next term will be a power 4 and b. The next one will be a power b and b power 2. In each case, the powers should be totaling to 5. We said so. So a power 5. This is power 4, but this one is to power 1. So they are still totaling to 5. Power 3, this one power 2, still totaling to 5. The next one, 3, a drops to 2 as b raises to 3. Powers still totaling to 5. A power 1 and b 4. Then a goes to 0 as b ascends to 5. Therefore, now we insert coefficients. We insert the coefficients 1, 5, 10, 10, 5, 1. So this one becomes a power 5 plus 5a power 4b plus 10a power 3b squared plus 10a squared b power 3 plus 5ab power 4 plus 1 times b power 5. The expanded form raised to power 5. Raised to power 5. For power 6, we use the coefficients for 6. Power 7, the coefficients for 7. Note, you don't have to cram these coefficients. They are given in the maths table at the back. So in the 4-figure table, we have the binomials coefficients or the Pascal's triangle, the values given there. So you can be referring to them whenever you're doing an exam. Let me give another example. Then we will be good to go as you'll be waiting to see further examples on this. If you are taught, for example, expand x plus 4y, x plus 4y power 3, expand x plus 4y plus 3. Solution. We should note that as the powers of x will be descending, the powers of 4y should be increasing. Therefore, we will start with x when it's power 3, but 4y to 0. The next term, x will go to b squared now, but 4 power 3y will be to power 1. The other one, 1, but 4y b squared now. Then lastly, x goes to 0 as 4y becomes cubed. Therefore, this one is x power 3 plus x squared by 4y. So we will have 4x squared y. 4x squared y plus 4 squared is 16. Y squared plus this one becomes 1. So x inertia 4 power 3 64 y cubed. So these are the terms without coefficients. So the coefficients of 3 are 1, 3, 3. Coefficients of 3 are 1, 3, 3, 1. So we insert them in the terms. We shall have this one by 1, x power 3 plus this one by 3 becomes 12x squared y plus this one by 3, 16 by 3, is it 42? 48 x y squared plus 64 by 1, 64 y cubed. Therefore, this will be the expanded form. Therefore, we first of all expand without the coefficients. Now, because we know the coefficients either from the table or from the Pascal's triangle, now we insert the values or the coefficients in the corresponding terms and we will get the final expansion. We can try the last expansion with a negative now. With a negative. If you're told expand 2x minus 3. 2x minus 3 power 4. 2x minus 3 power 4. 2x minus 3 power 4. Expand. Expand 2x minus 3 raised to 4. We should know that as the powers of 2x descend, the powers of negative 3 will ascend. Therefore, we'll have 2x with the whole power, but negative 3 to power 0. The next term will be to power 3 now, but negative 3 to power 1. And the next term, 2x squared, but negative 3 now to power 2. 2x power 1, but negative 3 power 3. And lastly, 2x as it goes to 0, negative 3 will get to power 4. We'll get to power 4. Therefore, 2 power 4, which is 16, x power 4, because each term is being raised to 4. Then negative 3. Okay, we have already 2 power 3, 8, x power 3 by negative 3. So we get negative 24. Here, now negative 3 squared, it becomes a positive. So it's 9. 2 squared, it becomes a 4. So plus 36. This is 4, this is 9. And x is squared. This becomes a minus because negative 3 power 3 becomes negative 27. Negative 27 by 2 becomes negative 54. X is to power 1 plus this becomes a 0. 3 negative 3 by 4, it will be positive because the power is even. So positive 81. Positive 81. So this is the expanded form without coefficients. And the coefficients of 4 are 1, 4, 6, 4, 1. Therefore, we insert them now. We insert them in the expanded form. So we'll have this one by 1, 16x power 4. 24 by 4 is it a 96? 96x power 3 plus 36 by 6, which is 216x squared, minus 54 by 4, which is 216 again, plus 81 by 1 is just 81. So the expanded form will be this one. During your own time, you can expand 2x minus 3, 1 raised to power 5, expand to, or let me give it as a minus raised to power 3, and finish by expanding 3x plus 4b, this raised to power 6. So expand this, first of all without coefficients, get the triangle, the Pascal triangle coefficients for power 6 for that case, power 3 for this case, power 6 for this case, insert them and get the final expansion. So thank you very much for following. In the next lesson, we'll be seeing how the binomial expansions now can be applied in numerical computations. Thank you very much for following.